our next keynote profile, Rajendra Ugrani, researcher and leader AI/ML Security Software, California, USA. His expertise includes machine learning and AI systems for large-scale platforms, relevance and recommendation system for social platforms, conversational AI and natural language processing (NLP), weekly supervised learning for intelligent conversational agents. His today's topic is advancement in agentic AI systems and reliable agents at scale. With that, let's welcome Rajendra Ugrani.
Hello, everyone. Let me just share my screen here. Is a screen share?
Yes, sir. We can see that.
Okay. Hi, I'm Raj, and good morning, everybody, or good evening, or good afternoon, whichever part of the world you are in. I'm going to be talking about something really I'm passionate about, something I'm currently working on, and something that is recent as well. This is about agentic AI system. Over the past couple of years, we have seen incredible advances in large language models. You guys must have seen when the ChatGPT was released, like what an impactful event that was all around the world. But the real shift is happening now is the emergence of agentic AI systems, systems that can reason, that can plan and take actions, not just answer a question to a prompt that the user is giving. So in this talk, I'll discuss how these systems work, the architecture behind them, and most importantly, how we build reliable agents that can operate at scale in real production environments. Though I would say that my goal is to convince you that agentic AI system is not a AI or ML problem. It's actually fundamentally a system problem. So with that, here we go. We are moving from AI that answers question to a AI that perform task and keep a tab on it. Over to the next slide. All right, so I'll start by briefly discussing the shift from the traditional AI models to the agentic systems, how our frontier models are able to answer a question to a prompt. From there, how it performs a bunch of tasks and actually coordinate between those tasks as well, and how we can actually reliably scale those agents. Then we look at the core architecture behind the modern AI agents. After that, I'll talk about some of the reliability challenges this system introduced because of the nature of it. Then we'll look at engineering patterns that help build those reliable agents. And finally, I'd like to discuss what it takes to run these systems at scale in production. All right, let's briefly talk about the shift from the models to the agentic system. I have a picture here which actually gives you a brief idea about what are the difference between a traditional AI model, a frontier model, or a foundational model, and an agentic AI system. So traditionally, AI systems have been built around models that generate responses. Yes, the fundamentally AI frontier model is critical and most important layer of the agentic AI system. You give them a prompt and they return an answer in a traditional AI model. But the next generation of AI system goes well beyond that. These systems can reason through problems. If you tell, hey, I want to actually book a flight from New York to Chicago and then Chicago to San Francisco, and there's a 2-day layover between these two. I want the cheapest ticket. You give the constraints, you give the context to that, so it can reason through the problems. It actually plans multiple steps. What are the things that needs to be done? What are the constraints that's been given to the system? It can call external tools or APIs or services, and then take actions on the behalf of the user who are actually managing those agents. So instead of a single model inference for a question and answer, which is actually to the core of the system itself, so we now have orchestrated workflows involving models, tools, and data systems. The shift from models to agentic systems is what enables AI to move from answering a question to actually performing the task itself. Moving on, let's talk about. I actually briefly touched on this. Let's deep dive into what is an AI agent. So, an AI agent is not just a model. Model is actually the fundamental core part of it, but it is a system composed of several components. At the core, as I mentioned, it's the reasoning model. LLM is, it's another term for it, a frontier model or a foundational model. So a typical large language model that decides what to do next, actually. So agents also need tools and APIs so they can interact with external system, things like, searching the code base or searching the web or databases, enterprise systems or enterprise database layer or different services. So they maintain its own memory as well and a context, what needs to be done next, what are the tasks that needs to be done. How do we reason about things? What are the context given to it? What are the constraints given to it? So, and it also tracks the progress of each of the tasks that are given to it. And once each of those tasks are done, again, orchestrating those information that is coming from each of those sub-agents and then actually reason through that. Then it has a planning or control loop, allows the system to break the complex problems into multiple steps. And finally, they rely heavily on the data access layer to retrieve relevant information from enterprise data system. So I'd like to give a small example. Recently, I had a real need to actually book a travel ticket with multiple hubs and multiple constraints. So I simply asked my ChatGPT to give me the best possible deal, searching all through the web. It actually did a pretty nice job, though not perfect. So we are not still in the perfect world. So we are getting there. So it took all the constraints that are given to me. It took about 30 minutes or so, but it did a pretty good job of searching different travel agent websites for different deals and presented me with, hey, these are your options that you can take. So the way to look at the AI agent is actually the LLM becomes, even if you say, hey, I want to actually book a ticket, the LLM is still the core part of it. Actually, even to break the task down to multiple steps, it still uses the AI model, reasoning model, saying that, hey, these are the constraints given by the user. Now give me the task itself. Then each of those tasks are actually independently tracked and then orchestrated behind that. So next, let's talk about the agent execution loop. As I mentioned earlier, this I actually, in a way, I would like to think of this actually a four-step process. It observes and then plans, then acts and evaluates the results itself. So the most agentic systems operate through an execution loop. The first agent observes the current state. Hey, this includes the user's request, what is the available context and constraints and the relevant data that is given to it. Then it plans the next step required to accomplish the task. Then the system acts, which typically means calling an external API. In my own example, it was about calling the Google Flights service, maybe Kayak as well, maybe other travel agent websites, and retrieving those information for it. Finally, the agent evaluates the result. Once the result comes back from those tools, it evaluates and determines whether the task is complete or if another step is required or another layer of reasoning required. So it's actually the reason it's a loop is because until those constraints are met, until those results are evaluated, the task is not complete. So once it determines that the task is complete, then actually it exits the loop. So the loop continues until the objective that was given to the agent is achieved. Uh, so the role of data in an agentic system, as I mentioned, becomes very, very, very important. So in my case, it did not need enterprise data because it was a consumer in a use case. So it actually did the web search. So that is the data that was needed. Hey, what are the possible ways we can book this ticket? But in a real enterprise world, there's a lot of data and context, additional context required as well. The data that is given to the LLM or the LLM is trained on is not nearly enough because it doesn't have the personal context that the user is currently asking or the agent's objective is supposed to fulfill. So most organization, the real value of agentic AI comes from connecting models to enterprise data. So agents rely heavily on retrieval systems to access relevant information from internal knowledge databases, documents, additional databases as well, like techniques like retrieval augmented generation. You must have heard about this term called RAG. So it's actually, there is a LLM model, it needs additional data, so it goes to the database, actually grabs the data and connects to, gives that additional context to the model evaluation itself. So allows those RAGs allow models to combine the reasoning with enterprise data. So agent can also interact with structured data systems like a JSON object, for example, or a SQL output, which are actually structured output, not just web searches or free texts coming from the web searches. So this structured data system and services, it will interact. So this makes so what we have all this data coming from it. So the data governance becomes very, very, very key to the development of agents itself, like things like data governance, access control, security, for example. These are extremely important when deploying the agentic AI systems. So that poses a reliability challenges. It's not just about getting the answer, getting the objective fulfilled. What are the security loopholes that it can actually pose, for example? So these are very powerful systems, but they also introduce new reliability challenges. First, models can hallucinate. We all know that this is not agentic AI system problem. This is actually foundational layer problem itself by the models. So this hallucination is producing outputs that appear reasonable but are incorrect. So if you actually really dig into it, saying that, hey, it might even say that, hey, you got a ticket for ticket booked for $100. Is it really true? I mean, in my case, it was true, but there's no guarantee of it, right? So that's called hallucination. Secondly, agents rely heavily on external tools and APIs. So, for example, if my agent is actually relying on a Google Flight website to track the prices, what if the Google Flight is down? The service itself is down, or the internet connection is down. Agent cannot access information. What if it doesn't have the necessary permission to access those information? So that poses some reliability challenges. Third, because agents operate through planning loops, they can sometimes get stuck in unbounded execution cycles. For example, as I mentioned, every agent has some objective to fulfill. Let's say that every time I actually respond, some sub agent got the output that he wants, evaluates, it says that, hey, I'm not there yet. This objective is not fulfilled. Let's go back and actually reason more about it, get more data. It actually does that again. Again it finds itself in a loop that, hey, this is not fulfilled. I need to do it again. So there is a possibility that it can get stuck in that unbounded execution cycle. So it's important to monitor those execution loop and then actually have a correct exit conditions. Security risk is something that I already mentioned. There's always security risk. It can actually, for example, agent having information about sensitive data. In the enterprise world, it can actually grab some sensitive data the agent is not supposed to have access to. So things can go really, really wrong. Even in web searches, for example, if it searches for a web and the web searches came back with additional prompt, what do you call the prompt injection, that tells models to do stuff that it is not supposed to do, for example. So there are security risks, every step of the way. Then finally, the debugging these systems are really, really hard. This is not just debugging through a deterministic code that we engineers are used to. So it involves debugging these systems through multiple multi-step reasoning workflows. So that can be hard as well. So that brings us to what does it take to build a reliable agent, engineering those reliable agents. Again, as I mentioned, these are not in a way new system problem. This system problem always existed. How do we always build a reliable system, for example? But AI is posing additional challenges at us. So building reliable agentic system requires applying strong engineering practices. One important technique is, for example, structured output. If you're building agent, you exactly know what should be the output. So you actually look out for that, where models are required to produce responses that follow a schema rather than the free text. So that could be a useful tool as well. Putting guardrails and validation layers help ensure that actions are safe before they're executed. Agents also interact with external systems through well-defined tool interfaces, which makes the system more predictable. You might have heard about MCP, for example. So in many production systems, a human in the loop step is added for high-risk decisions. If the decision that AI is taking is high risk, you put a human in the loop rather than autonomously, letting it take action. Finally, strong observability and monitoring are critical for understanding how agents behave in production. So building this system requires some additional, as I mentioned, it poses additional challenges, but at the same time, we do have the tools to monitor them. So we're still in the early stages of those, journey. I know things, as I mentioned, things are not perfect. I think, as a engineering community, we are moving in the right direction. That's my belief. The next thing I want to talk about is the scaling those agent system, like latency management. Does it give the response in a stipulated SLA, for example? What is the cost of optimization that we can do? So multi-step reasoning workflows can increase the latency since agents may perform several model calls and tool interactions, like calling an external API, external database. So cost optimization becomes important because each step may involve model inference and external services, and this can get expensive if you do not monitor those. At scale, organization must build system for workflow orchestration that coordinate models, tools, and data systems. It's also important to establish strong evaluation and monitoring frameworks to understand how agents perform in real-world tasks. So many organizations these days are now building, internal platforms, a bespoke platform for their, own use cases, specifically designed to support large-scale agentic AI systems. So in a way, the hardest part of agentic AI is not the model. The model is solved. The problem of the model is solved by an external foundational layer, entity. So we have OpenAI, Anthropic, Google, XAI, Meta. So they're solving those agentic AI model problem. But the hard problem of building those agents and like deploying those agents is actually the infrastructure around it, not the model itself. I have it's a reference architecture. This is not something that everybody will follow, has to follow. But I believe that every agentic AI system is being built is actually has a version of this architecture. So at the top are applications and user interaction. This is actually, at the top, me sitting and saying, hey, I want to actually, go through all the available, booking options and, decide on the best possible option for me. Then there is a agent orchestrator that manages the planning and execution workflow. This is actually the agent say, hey, should I go to Google search or Google Flight? Should I go to Kayak as well, or should I go to something else as well? This is the planning and orchestrating. Then there is a reasoning model, which is the heart of the system. Typically, a large language model called GPT or Claude that determines what action should be taken. This is actually helping the orchestrator. Orchestrator is asking, hey, how do I split this into multiple tasks? How do I reason about the data that is coming in, right? So the LLM becomes a critical heart of the system. Then the agent interacts with external capabilities through tools and APIs. This actual API and the data that is coming from the web search or internal systems. Then there's a retrieval layer that that connects system to enterprise knowledge and data. And at the foundation are enterprise data platforms like Snowflake, for example, or any other data warehouse system that you're aware of. So which provide the data that powers these systems. So to summarize, key few points that I've been talking about. First, AI is evolving from standalone model to agentic system that can reason, plan, and take action. Secondly, connecting agent to enterprise data systems is essential for real world value. Third, building reliable agents requires strong engineering practices. This is not going away just because a model or AI is coming. We need more robust engineering practice more than ever, including the validation, monitoring, and putting those guardrails in place. And finally, deploying this system at scale requires robust infrastructure and platforms to support the actual workflows that enterprise needs. So the future of AI will be defined not just by better models, but by better systems built around them. With that, I think I'll conclude my talk here. Thank you for the opportunity to present my views here, and appreciate your time listening to it. And if there is any question, I'll try to attempt.
Thank you for such an informative keynote address. Your insights were extremely valuable, and we are sincerely appreciate your contribution to our conference, sir. Thank you so much. So if any participant has any question, they can raise their hand. So as there are no questions at this moment, thank you so much, sir. So let's